Okay, so welcome to the forum talking about CXL and the ecosystem. XConn Technology is a startup company, about 4 years old. So we have a product that is a CXL Switch. So I'm going to uh, talk about the switch, how that can be fit into the ecosystem, how that can be utilized for the, previously mentioned all kind of purpose, basically for the AI computing. I think that's a focus on everybody's mind. So just very briefly, this is our product. So it's the CXL 2.0 switch, and this is our ASIC. It's not a FPGA. So we have this test chip sample almost a year and a half, actually over 1 year and a half. So there's a lot of validation, verification work already done. The chip is a fairly big silicon. It got 256 lanes and total 2 terabyte per second switching capacity. Because the CXL is built up on top of PCIe Gen 5, so the chip is also a PCIe Gen 5 switch. I will talk about a little bit on this perspective later in my presentation. But let's focus on the CXL side first. The chip is being built just fit into this CXL and AI computing area. So as I previously talked about, for the memory application, memory pooling, memory sharing, all these applications, the latency is kind of very important. And so far from our measurement of the real silicon, our chip has the lowest port-to-port latency to support the CXL memory pooling and sharing. Also, we're just targeting this segment of CXL and AI computing, so it's got the lowest power consumption as well. The chip also has so many ports and lanes. The 256 lanes can get bifurcated to be by 8, so that's get to the 32 combined ports. So each port can be both uplink and downlink, can connect to the servers or connect to the end device. It is programmable. So the chip also support CXL 2.0 standard. So all the fabric management function is fully supported. And also in the process of making this switch, we also received a lot of customer requests. They think, the memory pool, some of our customers, they really want to have a really large memory pool, right? To support that, one single switch is kind of, although can support a very big, it's not enough. So our chip also, at this CXL 2.0 stage, we are building in the switch cascading feature to allow this memory pool to be really composed of a number of switches, so can go to a very large memory pool size. So the chip is right now, our silicon is a customer sample right now, and we're getting the chip going to be mass production in the middle of this year. Right, so next one. So let me talk about some of the supported feature for the CXL switch. So as I mentioned, a 256 lanes, we do the by 8 bifurcation, but it also supported by 6. So in the maximum case, it can go up to 32 ports, right? But if you do some by 16 ports, that obviously going down some port number, but that's kind of the total capacity. Our switch right now, as mentioned, it supports CXL Fabric Manager. The way we designed the Fabric Manager is this Fabric Manager will running on an external host, either a x86 or ARM processor powered by a Linux operation system. Will get handling all these Fabric management functions. And to support, the Fabric management function, it also supports MCTP protocol that on top of PCIe or the I2I2C interface. So our switch support both. And the chip also supports multiple VCS. This enables the kind of multiple hosts to share a common memory pool. The CXL 2.0, also defined MLD. So our switch also designed to support both SLD and MLD devices. Then the memory pooling, because the memory module, some of the module like E3.S, they can conveniently do the hot plug. So our switch also supported the function of hot plug and removal of CXL memory devices. As I mentioned, the switch, because the customer, they seeing a very large memory pool, so the switch support cascading. Although the cascading or the inter-switch connectivity is being defined in the CXL 3.1 or 3.0, at this stage, our chip already support switch cascading. Then to build the real system, we also have support of these RAS features being defined in the CXL 2.0 spec. So just give you some quick diagram of how this memory pooling and sharing system work. So this is a very familiar diagram if you are following the CXL consortium. In this picture, there's a couple of functions. At the top, H means the host, which are the servers. In the middle is a switch, and then there's a function called a Fabric Manager. And the bottom, those devices, CXL memory devices that attach to a switch, actually, a number of them, they become, a memory pool, right? And as I mentioned, the CXL switch from XConn, our switch support cascading. So you can imagine not only one, you could put multiple switches cascaded with each other or to a kind of a tree architecture where this memory pool can grow really, really big. And the CXL ecosystem is kind of new, right? But in the past year, there's a lot of real product being developed. And in the past year, we have also worked with all these CPU that support the CXL 1.1, which, Intel and AMD, they both have processors that support CXL 1.1. And we are also under the way to support this year's release of CXL 2.0 processors. So things are kind of ramping up very nicely from here. This is more like a diagram that shows in the basic of memory pooling sharing system. This is actually a diagram that we have in our lab from the very basic, right? Because you have multiple hosts, means you have at a minimum two servers, and a pool the minimum two of the CXL devices. So that is kind of what we build in a prototype system in our lab. And based on this system, we develop all the software SDKs, all the supporting Fabric Manager functions to be able to demonstrate and also be able to do the testing of this memory pooling sharing system. That was a diagram, and this is the hardware, how that system is being put in together. So on the server side, we have a retimer card, and in the middle is our CXL switch. This is actually a fair big switchboard. That's kind of our reference design. So the reference design is more for the internal development purpose, but also some of our partners or customers, they take this system for their early testing and the software development as well. On this big switchboard, of course, in the middle, you can see our chip is underneath heatsink, and on the board there's a lot of MCIO connectors. So the system kind of being from the server, you have this retimer card. The retimer card has MCIO cables, and these cables connect to the switch. Right. On the switch, there are already two of the standard by 16 cam slot, allow you to plug in some of the CXL memory devices. But all these MCIO connector can further fan out through some expander card. For example, this is a card that fan out 6 of the PCIe cam slot, and this is a board that fan out to 12 E3.S devices. So this kind of setup, we would be able to do multiple hosts and multiple of the CXL devices. Then, as mentioned, another important function is this Fabric Manager function. So here we have, in our setup, we do a ARM-based platform that run in the Linux and handle all these Fabric Manager function, with a connection to the switch using PCIe I2C or the UART interface. And we do provide SDK and Fabric Manager function and get tested on this kind of platform. So XConn is a chip company, right? But nowadays, the chip also need to get a lot of software support. So we do support, we do provide, supply the software SDK that works really well with our chip at a lower level, right? So this is the diagram that internally how we use, how we develop our software SDK to support all the mentioned function of memory pooling, memory sharing. So you can see this is our hardware, but on top of that hardware, there are a lot of library utility allowed all these SDK to really interact or being able to program the switch at a very low level. Then we also have the CLIs to do this some basic setup configurations, some of the memory mapper APIs, and on the top we do have support the Redfish interface for the further, data center or this system integration. So this is our SDK. We provide this SDK to our partners, to our customers, and they take this SDK to do further development, to meet their software development or their system needs. This is a picture that shows a real hardware that is using our switch. on this system, you can see this is a big kind of heatsink. Underneath is our switch. And the switch kind of fan out all the port to the CDFP connectors. So this picture actually only shows the half layer of the board, where you can see there's 8 by 16 ports, CDFP ports. As mentioned, we have a fabric manager, and this fabric manager is actually running x86 CPU, because either the ARM or the x86, they are powered by Linux. So some of the software can be easily ported between the two systems without too much of the work. And here is the performance measurement we have done, or our partner have done, using the configuration mentioned before. So on a 2-socket server, there's a local CXL device. There's local DRAM or DIMM. And you also connect to a switch, where at the switch you attach CXL devices. So the latency being measured using the Intel MLC, we see that for the local CXL device, the round trip latency, the idle latency, is 260 nanoseconds.
Hey, JP, there's one question here, if you don't mind.
All right.
The question is this a EMR/GNR server platform that's available today?
Yes, this is based on the EMR Intel server, yes. So the local CXL, we measured 260. But if the CPU 0 through the switch to the CXL device, we measured the latency, idle latency is around 500 nanoseconds. And because it's a dual socket system, if the CPU 1 have to access this CXL device, it'll add further latency, because it have to go through this UPI interface. And essentially this 120 kind of double and added to this number. So that's the current latency number we measured, and we have. Of course, there's a lot of improvement still going on to further reduce this latency number. We heard from both, the processor guy and the CXL device guy, as well as ourselves. Our roadmap for the next generation, our switch, going to further reduce this latency significantly. So things will only get improved from here. Right. And this is the bandwidth measurement using the MLC. So this picture shows just a by 8 CXL device bandwidth measurement. The red line indicates the directly attached CXL memory, and the blue line is a CXL memory device attached to the switch, and then switch connect to the server. So from this picture, you can see this red line and the blue line, they kind of overlap without much of the gap between the two. Okay, so also want to talk about what's being enabled for the CXL 2.0, what can be done. We talk about, through the switch, you can build a very large memory pool. And this memory pool is, of course, that's good already for the memory pooling, where, Memverge, they have their software that's already running to do the memory pooling. But another important aspect of the CXL memory is you can already enable some of the memory sharing through the software. And that memory sharing, although this stage is only software-based, is already provide a lot of benefit for the AI computing. So we already know and compared that, memory sharing with the RDMA kind of approach, we do see this being the bigger advantage. First, much lower latency, right? The RDMA going to be kind of tenths of a microsecond, where the latency on the CXL, as I showed the picture, at this stage, through one of the switch, you can go about 500 nanosecond instead of tenths of microsecond. And the CXL memory sharing, the modeling is a kind of memory load and store. This is more energy efficient than the RDMA getting the data transported through the network. Also, the programming load store is much simple than managing the network transaction, make sure all the data arrival and so on. So that actually simplifies the programming. Also, the CXL support memory coherency. That's already an advantage for this CXL system. And also the switch we mentioned, we already support cascading, and we're going to get it further supported at CXL 3.1 stage. So the scalability to a very large memory is going to be relieved at this stage, right? We kind of hear a lot of people talking about this memory wall and talk about the AI model, the LLM model, they kind of double, triple, or quadruple every year or every couple of months. And the memory just not enough. This is going to get helped by this CXL memory, where a lot of scalability. You can expand the memory to tens of terabyte or up to 100 terabyte by cascading a number of switches together. So all these new technology, with everybody working together, actually going to get to a solution that really lower the total cost of an AI system. So we do see a very promising feature. The CXL memory sharing will boost the performance of AI computing. And that ecosystem is formed right now and progressing really, really fast at this moment. All right, so then let me talk back a little bit about our product. As I mentioned earlier, our product is a switch, a 256 lane switch, where it's a CXL switch, but it's also a PCIe switch. So this product, as of today, there could be three usage case, three kind of different usage, triple usage, just with one single chip. So you can use it as a PCIe switch, purely, PCIe only, or purely, CXL only, right? So PCIe only means you can build the AI system with the GPUs, network card, and the CPUs to become a computing system. And CXL, you can do this to a memory pooling sharing system. But another usage is our switch also support this called hybrid mode. Means our chip support both CXL and PCIe at the same time. That's because at this stage, the CXL ecosystem is just coming up and forming, but there's still a lot of legacy or PCIe devices. They need to be included in this heterogeneous AI computing system. So our switch would be able to support any kind of partition of PCIe and CXL. You could do 50-50 PCIe CXL. You could do, 25%, 75%, however you want to partition it, because the software will be able to configure each port to be CXL or PCIe or kind of mixed mode operation. And the nice thing is you can design the hardware for now, and you can even later change the attached device, and you don't need to redesign your hardware. You just need to reprogram, rewrite your software, do some software changes. Okay, so talk about a little bit on the roadmap and the future. We do want to point out, XConn as a pioneer in this CXL switch. We have a roadmap that going to lead us to a CXL 3.1 switch, PCIe Gen 6 switch for the sample next year. And we imagine, because the CXL ecosystem have been growing and forming nicely, at the CXL 3.1 stage, there actually going to be a unified ecosystem that work around the CXL. So at this stage, we see, CPUs, GPU accelerator, network card, memory storage, and in-memory computing devices can all come together, get connected, and communicated efficiently through CXL switch. And the software development around this system going to take a while, right? But eventually, with this kind of good foundation, good connectivity, connecting all the devices, we imagine the AI computing system performance will get boosted tremendously, and the cost also going down tremendously as well. All right, so that kind of end to my presentation. So the call of action is, encourage everybody to join the CXL consortium, and we all collaborate on the next generation AI and the computing system using the CXL. And yeah, if there's an advanced system that you have in mind to design, yeah, we can work together to build that system. So that kind of end of my presentation. I can take some questions from here.